Hello and welcome to this presentation on some of our recent enhancements for turning in ESPRIT TNG. We're going to talk about start and end positioning type, which will affect how the tool is positioned at the beginning or end of a feature. We'll show an example of the transition clearance, which will help avoid fully enveloping the tool when alternating contouring passes. And we'll talk about shifting the control edge of a grooving tool for contouring operations for better accuracy and precision. We also have some user interface improvements for turning, including the ability to see simulation coordinates as a radius or diameter, and improvement of graphic views to make programming even easier. Let's get started in ESPRIT by creating a new default metric document. And we'll import a CAD file, which is found in the training files. As you can see, the part is oriented along the Z-axis, which is typically the most familiar perspective for a turned part. The front view, top view, and side views don't work well here. Instead, we can use the ZX orientation to get the most familiar perspective and orientation for a turned part. We can also use the F4 key to access this view. Now let's go to the part setup and add a bar stock. Since the part was aligned along Z, the default work plane adds the bar in the same orientation and the correct stock is immediately created. Let's press OK and validate the part setup. Now let's edit the machine setup, and we'll pick a machine also found in the training files. Let's add a fixture. And we'll add the D5 to D200 chuck. And we'll add our workpiece. And here we'll just need a translation on the workpiece of 115 millimeters. Next, let's import our tools. Let's go back to the part view, and we'll recognize the turning features. Let's take the Z-axis as the revolved axis, and we'll recognize our features. For the front OD contour, let's import a process. Let's use the OD roughing process. Let's go ahead and simulate this part. We can see again that the front view and the top view aren't really ideal for a turning part. Because of the tilted axis, we can use the ZX view, which provides a perspective from the ZX plane of the machine coordinate system. This is the perspective that should be most familiar for a turning part. We can also switch between displaying the radial and the diameter displays in the simulation status window. Let's add a few additional operations. On the front OD groove, let's open the process OD grooving, and we'll open the process groove finish contouring. Let's hide these first two operations and focus on the last. It'll also help if we hide the solid body from view, and let's zoom into the tool. Notice how the tool is horizontal from the start point of the feature. If we go to the Strategy tab, we can change the start positioning type to normal, and let's edit the operation again, and you can notice that the touch point of the tool is along the feature start point. Now let's change this to blend in, and we can see how the behavior changes as the tool enters into the feature itself. Let's change this back to horizontal, and then let's look at the contour page. Let's change the machining area to alternate so that both horizontal and vertical passes are created, and we'll change the transition angle to 90 degrees to recognize the vertical walls. And let's simulate the result of this operation. As you can see, on the horizontal pass, the tool is going to be fully enveloped against the wall, which could be bad for the cutter. Let's go back to the operation, and we can add a transition clearance of 1 millimeter, which will break up the tool path. Let's simulate again. So that the tool retracts just before reaching the wall to avoid fully enveloping the cutter. Let's edit the operation one more time. This time let's set the control edge shift to yes in case the width of this groove is highly critical. This will ensure that we have a precise length compensation output along the horizontal movement in the tool. Let's take a look at another quick example for turning views. Let's open this ZXView saved file. Let's go ahead and simulate. And we can see that we're using a tilted table at 45 degrees. The ZX view is not always going to be the ideal view. In case we're not sure, we can always use the normal to view to give us the active turning plane using the active work offset.